Hello and welcome back. This is Barrett from the C4 Cyber Club here at Cypress College. And in this video today, we're going to cover the Security Plus Lab series, Lab 19, Cryptography Concepts. So essentially, we're going to be looking at a little bit of steganography and also how we can use some basic Linux commands to also hide zipped archives, particularly using the cat or concatenate command. So first thing we'll do is come to part one. So we're going to be using Steghide to hide hidden messages. So this is a Linux command line tool. So we are using the Kali machine, and we'll go ahead and launch the terminal. And first thing we'll do is navigate to the temp random directory. And if we do ls here, we see we have a handful of files. But first, we're going to create a new text document. So we'll use the nano text editor for this. So we'll say nano secret.txt. And you see we have a blank slate here. So we're going to add in a message. It's going to say secret message goes here and a password. So we'll say secret message goes here. No reason why each word is capitalized, but I'll just follow along with the lab. Password at $, hashtag Jones, $. Okay, so to save, you can just press Control X, and you'll see down here, it'll say save modified buffer. So we'll say yes. Now, if we do ls again, we see that we have now created this secret.txt. So let's use Steghide to get info on this earth.jpg. So Steghide info earth.jpg. And you can see that it tells you the capacity. So this is basically how much space hidden files that you could put inside of this JPEG. Try to get information about embedded data. We'll just say no because there is no embedded data in that yet. So what we could do, we could also check to see how big the secret.txt file is, which is a very small text file with just one line. So we know it's probably going to be pretty small, but we can go ahead and check that just to be sure. And we see that it's actually only 45 bytes. And we technically have over 5,000 bytes available in the earth.jpg. Now, a part of this lab is also seeing how the integrity of a file can change. So what we could do is check the SHA-1 hash value of the earth.jpg. So we'll run SHA-1 sum earth.jpg, and you'll see it gives us a hash value here. So I'm going to go ahead and copy this. Just right-click, copy. Let's come to applications, accessories, and we could use LeafPad just as another kind of notepad. And we could say earth.jpg SHA-1 sum original. And then we can paste that there. So we'll come back to that in a moment. All right, so now let's go ahead and we're going to run this command to embed secret.txt into earth.jpg. Okay, so now it asks for a passphrase. So this will be a passphrase that is also asked when you want to unembed or extract this secret file from the image. So we'll just call this secret. Go ahead and re-enter. All right, so you see embedding secret.txt in earth.jpg, and that's done. So now that this image has changed, let's look at the hash value again. And let me copy this. And we could say earth.jpg SHA-1 sum new. If I copy that, you see that the hash value is now different than the original. So this is a good example of verifying the integrity of a file. If this is an example where maybe you downloaded something from a website and you wanted to double check and verify that the integrity wasn't compromised during transfer, a lot of websites will actually give you the original hash value. So if you downloaded it and you notice that yours is different, this is obviously a problem. Something may have happened. It could be corrupt if maybe your packets were captured by a malicious attacker in the middle and altered. This could show a sign of integrity loss. And obviously in this case, we have a different hash value because we embedded this secret file into earth.jpg. And we can get info on earth.jpg and try to get information about embedded data. Let's go ahead and say yes now. And we'll say enter the passphrase, which is secret. Now we can see the embedded file is secret.txt and it is 45 bytes. And now let's say if we wanted to extract that, this is coming from a place where you know that there is a hidden file in this. So you could use Steghide to extract that secret.txt. Of course, it's going to ask you for the passphrase. And it's saying, okay, the file secret already exists. That's because it still exists from us creating it before. We can say overwrite row extracted data to secret.txt. And if we do ls, of course, we're going to see that listed here. We do ls-l. We actually see that it's likely updated with the most current time when we just overwrote that with this command above here. And of course, if we use the cat command to print that out to the screen, we see that we have the message here. Okay, so that pretty much covers Steghide and using this command line tool. And part 2, we still will be working with command line, but swapping over to using the concatenate or cat command to actually embed zip files together. So we're still in the random folder. And we see we're going to be working with this cybersec.jpg and also the secret.txt that we created. So let's first zip. We're going to create a new zip file called secret files. And in that, we're going to place secret.txt and dc.jpg. Okay. So now if we do ls-l, so here you can see we have the secret files.zip. And this, of course, is a combination of dc.jpg and secret.txt. So now we can go a little bit further and we could actually use the cat command to take cybersec.jpg and secret files.zip and redirect both of those into a new file named cyber.jpg. So it's going to, on the surface, it looks like it's an image, but as we'll come to see, it's actually more a compressed file. So let's go ahead and do ls-lh we see that cyber.jpg was created. And if you look at the file size, you'll notice that, remember, we combined cybersec.jpg and secret files. And if you look at the file sizes of these, it's looking mighty close to adding up to the 333K of this file here. So now if we were to treat this cyber.jpg, let's say if you are trading these secret files, you know that that is not necessarily a JPEG and it's actually a zip file. We could do unzip-t to, it's not going to actually unzip it. This is more of a test. It's going to tell us what's inside of it. You could see that secret.txt and dc.jpg are located inside of there because that is what is inside the secret files.zip. So that is just one example of using the concatenate tool to obfuscate files. All right, and now we will move to a GUI version of working with steganography. So GUI as in graphical user interface, and we'll essentially be working with StegUI, I guess you can call it, or it's steganography with a GUI aspect to it. Okay, so let's let me clear the screen here. We're going to run the file that's located in /opt StegUI bin, and then the file name. So I believe, yeah, this is case sensitive. So make sure you type it in appropriately. And you'll notice that this launches a window. So in this case, we're going to be working with audio files. So we'll go to File, Open File, and we'll search by audio files. And we see there's only one here. So it's bird.wave. So this is short for waveform file. We'll go ahead and press OK. We open that. Now, if we come to actions, we can embed. And we are going to embed that secret.txt. So we'll change show up here to text files. We'll choose secret.txt. The cover file is the bird.wave. And file to use as output, we can just choose to overwrite the bird.wave. Okay, and then we'll want to check this box here, overwrite output file. And the passphrase, we'll keep that at secret, the same as before. Press OK. All right, easy enough. So now we just go to info, get open file info. So you can see here it's asking for the passphrase because it knows that one is present. We'll say yes, type in secret. And now you can see the information for this. We have secret.txt embedded into this wave file. So otherwise, if you sent this wave file away to somebody else, it would play just fine. It would probably be a sound of a bird. But if somebody on the receiving end knows to look for a secret file in here, they can use Steghide like this to extract that information. So that is the end of the lab. It was short and sweet, but once again, this covers the Security Plus Lab series, cryptography concepts and steganography. Great. Thanks a lot for watching.